we have discussed object-oriented programming system and its features, the important and essential features of OOPS, like encapsulation, or ADT, and inheritance, polymorphism, which are being when executed by any programming language. You can say it is an object-oriented programming language, right? So in order to implement this, we said there are certain things which we need as programming construct, like classes, objects, constructors, destructors, and all, right? And we have discussed a bit about the different programming languages as well, which are object-oriented, and similarly there are certain languages who are object-based, right? And they also we have discussed, right, the difference between the object-oriented and object-based. Today we will continue the same and going ahead and continuing this object-oriented programming system. We will see the Is my PPT visible to all of you?
Yes, sir.
Yes. So last class we have even discussed about the inheritance as well, right? Why basically inheritance is required? It allows you to have the classes to be used again and again. I mean, the members of the basically class consists of what? The data and the functions. They are said to be its members, and these members can be further, used in its derived classes, okay, without having been coded, compiled, tested, debugged once done to the base class rather, right? So that is something like inheriting the property of a parent, the child, class, how the child will inherit the parent's property, where the property is being built by the parent by doing all required things rather, right? So which is readily to be used, which can be rather used by the children, kids, by just inheriting it. So similar fashion, the base classes, the parent classes, once coded, compiled, tested, debugged, all its members that can be accessed in derived class without having doing the same, right? So it is something like reusability of the members of the respective classes, other classes, by just inheriting. So this, an important feature, right, which is required in a real-time scenario. So, so this object-oriented programming system, if you see, most of its features are quite close to the nature, real world. So because of which it has become more easy, for the programmers now to implement the real-world problems by relating it with the programming constructs, that we have as part of the programming language, right? So inheritance, of course, allows the new classes defined in terms of existing ones by allowing them to inherit common parts. I'm just going to the slides after what I have discussed before. Inheritance addresses both of the above concerns. Reuse, ADTs. You can reuse the classes or ADTs after minor changes and define classes in a hierarchy. You can rather change, once get access to that respective, ADTs or classes which you have inherited. Like a child when inherit the property of its parent, then he can do certain modifications. He can renovate it. He can paint it and make some modification as per his requirement. All such things he can rather do it. But the basic skeleton will be that what parent has built, which is readily to be used, right? The same kind of scenario here we can rather see in programming languages, right? The help of this inheritance concept, right? ADTs are what do you mean by ADT? Abstract data type, which is like the class of the object-oriented programming system, programming construct, right? Rather, which is a combination of both data and functions together, right? Then you have the specification of the function defined inside, and you don't specify the operation to be carried out, rather, right? So that's how you say it's an abstract thing, right? When it comes for implementation with a concrete structure, then of course we can say it's an object, or it's implementable thing, or it's a concrete class, right? Class instances are called the objects. So when you instantiate, a class can be instantiated for several number of times in order to implement the class, right? How do you implement the class? By instantiating it. Instantiating is nothing but creating an instance or an object of the respective class, right? A class that inherits is a derived class, right? The class who derives, who inherits, the base class, is said to be the subclass, rather, right? A class that inherits a derived class, or a subclass we call it as, right? Or a child class. The class from which another class inherits is a parent class. So or a super class, right? Or the parent class, we can say, right? So the class from which another class inherits is a parent or super class. Fine. Subprograms that define operations on objects are called methods. The subprograms that you have, or the operations that you have defined inside this particular subprograms, which are being invoked for the objects, are said to be the methods. Fine. Calls to methods are called messages. Fine. When you are calling the method, of course, right, with the help of message, means you pass certain parameters to the formal parameters, the actual values that you pass, right? So that's nothing but a kind of message that you can pass on which you want your respective method has to be rather implemented, right? With the operation defined in that particular subprogram, right? The entire collection of methods of an object is called its message protocol or message interface. The entire collection of methods, the collection of methods that you have in that object, rather, right, is said to be the protocol or the message interface, right? The messages have two parts: a method name you have and the destination object, rather, right? Fine. In the simple case, a class inherits all of the entities of its parent. So a class who inherits, of its parent class, you can say in a simple remark, it's going to inherit its entity. Entities are nothing but the data and functions, of course, rather, right? In C++, you call it as function, whereas in Java, you call it as a method, right? Inheritance can be complicated by access controls to encapsulated entities. A class can hide entities from its subclasses. A class can hide entities from its clients. A class can also hide entities for its client while allowing its subclasses to see them. And how this is all being possible with the help of access, specifiers and visibility mode. Sometimes we call it as in C++, the same in Java, you call it as modifiers, right? Fine. So the access specifiers, or the access modifiers in Java, which you have, are basically private, public, protected. So by declaring the entities of the class, like data and functions, under different access specifiers like private, public, protected, you can prevent the users, like clients, from having access to certain credentials, rather, right? So the controlling of privileges to the users that is going to be done for the entities of that respective class can be done with the help of this particular access specifier, which I have rather discussed in the last class, right? Last class I have discussed about the access specifiers by taking the C++ as an example, rather, right? And the C++, if you take, you have private, public, and protected. So if you declare the entities under private mode, they can be accessible only within the class. Only within the class, in sense of the functions that you have associated with the respective class, in which you can probably have access to that respective data. But if you declare that under public mode, then they can be accessible within the class, within its derived classes, and as well through the object, right? Object is what the client is, rather, right? That we will probably export it, right? So if you want to hide it from the client, then probably you can give it as private or protected, rather, right? So protected members are also another access specifier that you find, right? So which when the entities of a particular class declared under this protected mode, they can be accessible only within the class and its derived classes, not through the clients or objects. Rather, right? You can prevent the access of the entities of that respective class from the client, but then you will be able to allow the derived classes or the child classes to have access to the same. Fine. So these kind of things, rather, you can probably do it with the help of the access specifiers or access modifiers, right? Besides inheriting methods, as is, a class can modify an inherited method. Okay. The new one overrides the inherited one. The method in the parent is overridden, right? Generally, when you inherit a base class, right, at the derived class, what happens? All the entities of the respective parent class can be inheritable at the derived class or the child class. So child class can modify the methods of the parent class, right? As I said, when a child inherits the property of his parent, he can renovate. It means he can override, right? So similarly, the methods of the parent class can be overridden at the derived classes, rather, right? There are two kinds of variables in a class, you find, right? Class variables are instance variables, right? The class which does have the variables inside, right? Like you have the its own data, right? And here the meaning has been taken in two different forms. One is the variables of the classes that you find, right, are nothing but the data of the same, fine, which is generally being declared under private mode, and they'll be accessible within the class. It means the functions of the class here. But then if you have an instance, right, instance variable is nothing but the object, right? Instance variable is nothing but the object, right? The class to be implemented. In order to implement the class, how do you implement the class? You need to instantiate it. Means you need to create an instance of that respective class, right? I hope this is all I have explained you in the last class. I can probably show you those with the help of the Jamboard that I have explained you by taking an example of C++. Right? We'll see if there are certain examples here also available in the coming slides. Those can be further discussed. Right? There are two kinds of methods in a class you find. The class methods that accept the messages to the classes, and instance methods. Means the methods that you define inside the class are said to be the class methods, right? They accept the message. I mean, they will have the parameters which are said to be the formal parameters. They accept the messages from the object when probably this method is being invoked to the particular object, right? You will be passing certain messages. These messages are going to be accepted in the class methods. Fine. And instance methods. The methods which you invoke through the object to implement, rather, right? So they accept the messages to objects. Fine. So they're going to be accepted for the object, rather. It can be implemented for the object, right? So single versus multiple inheritance. Basically, inheritance here. If you see, I've classified in the other class there could be of about 5 kind of inheritances: single level, multi-level, multiple, hierarchical, and hybrid inheritance. You can see in C++, all these 5 kind of inheritances are going to be implemented, but it's not going to be the same case with other programming languages. Like for example, if you go for Java, where you have single level and multi-level, but multiple as well can be simulated with the help of interfaces. Similarly, in other languages, these 5 kind are not being implemented. They're restricted with few, but for most of the languages, it support, of course, who is object-oriented, definitely a single level, rather, right, or multi-level. One disadvantage of inheritance for reuse is it creates independencies among classes that complicate the maintenance, right? So what happens because of this inheritance? There's a possibility that the class who is inheriting the base class, they can probably have the methods to redefine the same, and they can be but then when redefined, it's good. how they are going. There are two instances of the same method, which is one coming from the base and one is which is available inside the derived, having been overridden. So one has to be rather implemented as a kind of design issue, which is rather required to be looked after by the language designer. Of course, right? This is another, issue that you probably find when you deal with what do you call overriding option, right? And interdependencies also. You see, the method is dependent on the method of the base class here, right? So the methods of the derived classes able to sometimes depend on the methods of the base class. For example, if you have, let us say, student class and then you have marks class, right? Marks class is inheriting the, let us say, student class. So in student class, you have some methods such as read and print, where read method will read only the student details, whereas in marks, again, you have input or say input method, which is going to rather invoke the read method of the base class. So this input method is depending on the base class method, right? So you can find the interdependencies, right, among the classes. Fine. So how we're going to deal with it? In the sense that when you create an instance of the derived class, right, I not only have to rather initialize the members of the child class, rather I need to initialize the members of the base class as well, right? So the kind of design issue, which is going to be rather looked after by the language designer. So if you can see in C++ or Java, if you can see the members of the base class as well are going to be created in alignment with the derived class object when you create an instance of a derived class, right? And then in even constructors, if you have in the base class, then derived class constructor will take the responsibility of invoking the base class constructor to initialize the members of the base class. All these are being taken care, of course, rather, right? So these are some design issues which comes under when you probably deal with this inheritance, and they're all being here taken care by all these programming languages by adopting the proper solutions, of course, rather, right? So we'll see with some examples in the coming slides. Dynamic binding. Binding, basically, if you see in all the programming language, right, from C or before C, you find bindings are available in two kinds: static and dynamic binding. The variables, how they are being binded, right, with the memories, rather, right, or how a particular data is going to be binded with the variable, right? How an object, how a message, method call is being binded with the method, how an object is going to be binded with the with its concerned class, how the a program can be binded with the methods or functions of the library or the packages that are associated with the particular respective programming language, which are available in its library. So the binding, how does basically takes care is the issue again by it being taken care by the language designer. See, binding here, when I talk about binding, it's going to be done in different terms of the same. As I said, binding of variables with the data, or the binding of variables with the memory, rather, right? Or binding of method call with the method definition, a binding of an object with its concerned class, or binding of your program with certain library functions, right? Are the methods of a package that you have availed in your programming language. So how this binding is going to be done, right? They are being dealt by the different programming languages in different manner, rather, right? So if you probably see here, when I talk about object-oriented programming system, I would like to bring to your notice that the binding is basically deals with here variables or object, the other way around, or the methods I can talk about, right? So the binding of method calls with the methods. Right. Generally, in C language, if you see, they're going to be the compile time, that is before runtime, right? That is nothing but static binding. Fine. So in C++ also, when you come to rather, right, you find the binding of method calls to the method, of course, done at the compile time or the before the runtime. But then, if let us say function overloading is allowed, when you have the same function being defined multiple times with different operations, but when invokes, generally you invoke the function with the name, and the name looks to be the same at different places, but your intention of implementing at different places is going to be different, because you want the different operations that have been defined to that respective function in different places to be rather implemented. In that situation, in order to make the compiler to understand the function overloading concept, which has been introduced in C++, is being taken care with the help of function prototype concept, right? Or else if you go to Ada, you have protocol concept, right? Fine. So that way it is being taken care. What is function prototype? Function prototype includes the arguments in number, order, and type. Okay. So the way in which you have declared the you pass the values to the arguments, the order in which you pass, or the type of values that you pass, or the number of arguments that you pass. So taking that into the consideration, and the same function though being called at different times, right? The compiler can able to identify the respective function to be rather pointed to that respective call. Fine. By differentiating it with this argument in number, order, and type that we have discussed in the previous classes, right? How function overloading is being taken care implemented in C++ with the help of this function prototype concept. But then a return type, of course, we said, like in C++, is no way concerned with the function overloading, right? You cannot have the same function by changing the return type. Fine, it's not possible. But whereas if you come to Ada, where return type also can be taken to define the same function with multiple definitions, because Ada takes the protocol concept, right? It includes even the return type as well. So that's how it's going to differ from one particular programming language. If you see another programming language, how they have dealt with the issues that were being raised during the implementation of the different programming concept, right? So here, so function overloading, as we have seen, can be taken care at the compile time, But when you come to function overriding, or let us say method overriding in Java, when you have, right? When you have a base class, you have certain methods in the base class, and when you derive the base class with child class, then those methods available in the base class can be here available at the derived class. So derived class, you are redefining, innovating it, right? By having certain different kind of operation. Then what happens when you are trying to create an instance of a dynamic derived class, and then trying to invoke the method of the derived class, the same name with the same name method is available in the base class as well, which you have overridden in the derived class. So then which particular method has to be rather binded to that respective derived class object will be left to the system, because compiler will be in confusion not to know which method I need to bind and all kind of thing. So these kind of issues probably you will find in method overriding concept, or function overriding concept rather, right, of C++, right? So this is being taken care with different solutions. Fine, and this will be left to the operating system. Like in C++, it has been dealt with the virtual keyword, right? The base class functions, if they have been overridden, overriding is nothing but having the function prototype very same as that of your what do you call base class, and then defining it differently with a different operation, right? That's possible, right? But then when you have inherited the base class, that function must have been available in the derived class, and with the same prototype, you are again defining different operation in the derived class to bind at the time of compilation. The compiler will be in confusion that which one rather required to be binded to that respective derived class object. So it will be now then leave it to the system then what happens? The system will take care of looking at those two different functions of the same prototype. Which one is non-virtual? The non-virtual is going to be rather binded, as the operating system knows that virtual cannot be implemented. So I mean, this is how in C++ it was dealt with. Rather, if you go with Java, in Java you may find different kind of solution, rather, right? So the solutions are going to be different from one language to another language, rather, right? So this is all what we are going to here discuss in this subject. Fine. A polymorphic variable can be defined in a class that is able to reference or point to objects of the class and objects of any of its descendants, right? So this kind of solution rather adopted in C++, you can see. Fine. When a class hierarchy includes classes that override methods, and such methods are called through a polymorphic variable, the binding to the correct method will be dynamic, because which one has to be rather binded, they'll be not able to be decided at the compile time, rather it will be left to the system. So system will decide which one has to be rather binded. Allows software systems to be more easily extended during both development and maintenance process, rather, right? So in Java, if you see, we have an abstract method concept, right? So abstract keyword is going to be used. So base class methods will be, when defined, they will be prefixed with abstract keyword. And in the derived class, what happens, that method when being overridden, and you are creating an instance of a derived class, and when you are invoking that method, which one is going to be rather binded will be left to the system, and the system will know that abstract method cannot be implemented because abstract are not specific. So it implements the non-abstract, which is nothing but a concrete method, or the method of the derived class, rather, right? That's how what do you call binding of the methods, when the methods are being overridden of base and the derived then when happen. Similarly, in C++ as well, as I said, virtual is going to be used, right? In the base class, if I have certain method which is going to be rather overridden in the derived class, that function is going to be prefixed with virtual keyword, so that when compiler will be unable to decide which one out of it to be rather binded to that respective derived class object, when it is going to be left to the system, the operating system will know that virtual cannot be implemented. So non-virtual are the function of the derived class, going to be rather binded with that particular object. Fine. So an abstract method generally is one that does not include a definition. It only defines the protocol. It just has the prototype, and it doesn't have any implementation. It doesn't have any operation. And so, like in Java, this kind of approach has been adopted, rather, right? An abstract class is one that includes at least one virtual method. In Java, the abstract classes, you can have those abstract classes can be inherited, okay, but cannot be instantiated. Abstract classes cannot be instantiated. Got it? Because abstract classes are nothing but will have some generic, feature. It's like, for example, car name. Thing you don't find, but a company who is inheriting the car property can be implementable. For example, ambassador is a child of car class, I can say, right? So where car is an abstract class, car will have just the features. It will just define the features of the car, how the car looks like, what the functionalities of the car, and all kind of thing. But you don't find car named car available on the road, rather, right? So but then you will have ambassador car, you have Maruti car, you have what do you call Volkswagen car. So these companies are inheriting the base class, that is car properties, but then they are defining in their own way the design and the implementation. All that is going to be done in their own way, and this kind of instance can be implemented. I mean, Maruti you can see on the road, right? An instance of the Maruti car you can find on the road. So this is a child class of the car, you can say, rather, right? Which is implementable, fine. So this is the difference between the abstract and the concrete, right? Car is an abstract kind of thing, right? whereas the Maruti is a concrete kind of thing which can be implementable, rather, right? Fine. So you can see car cannot be instantiated. It means you don't find any instance of the car. You don't find car named car on the market. But when you can see its child classes, yes, you can find, right? So car can be inherited its certain child classes like ambassador kind of thing. Then they can be rather implementable, which can be rather driven on the road, rather, right? An abstract class cannot be instantiated. That's what I was saying, right? Car named car cannot be seen on the road, right? Because you don't find an instance of that car kind of thing. But then after having been inherited at certain derived class, and then defining the methods of all such abstract class, in its own way, and when it comes to implementation, then you can see its functionality and its operations and all, right? The design issues of OOPS language, the good number of design issues that you find when you probably start implementing the programming concept, the object-oriented programming system features, rather, right? The exclusivity of objects, how an object look like, and what privileges you give to object, and in what way object can restrict the clients from accessing the class data, and how far the object is helpful for the clients to implement that respective class and all kind of thing. It's going to be varied from one particular programming language to another programming language. Subclasses as types. Can you have subclasses as types, right? Like when you inherit the classes, you say it is a subclass, right? Type checking and polymorphism. Do you have type checking while passing the messages to the methods, right? Of course, it's going to be there, rather, right? In Java, you have strict typing, of course, right? Unlike C or C++. Single and multiple inheritance. Basically, you find single inheritance when you say it is an inheritance in most of the programming, but multiple inheritance you don't find in all languages. Like in Java, you don't find multiple directly, but then with the help of interfaces, you can be able to simulate multiple inheritance. Object allocation and deallocation. How the objects are going to be allocated and deallocated. Is it only runtime or before runtime? Like in C++, you have both the possibilities. You can have the objects can be created before at the time of compiling or during the runtime. But whereas in Java, you can see object allocation and deallocation is going to be done only during the runtime, rather, right? And object allocation is going to be done with the help of new operator, and deallocation will be taken care of by the GIGO, garbage in, garbage out. You have one object as part of the memory management. As soon as when the object scope is going out, that object is going to be deallocated. It means the memory occupied by the particular object will be released into the heap so that it can be used by any other object, rather, right? So whereas in C++, you need to do the deallocation explicitly with the help of delete operator. Of course, in C also you have this allocation and deallocation, fine, but we are talking from object point of view, so where C doesn't comes into being here, fine. We are talking this allocation and deallocation in terms of objects here, right? Dynamic and static binding. Fine. As I said, the binding of the objects to the classes it can be done during the compile time or can be done during the runtime as well, right? In C++, it is allowed in both the ways, but in Java, you can see only at the runtime, of course, right? So dynamically at the runtime. Fine. Nested classes, having a class within another class. Of course, it is possible in a C++. You can have you can define one class within another class, rather, right? So these are the different design issues. How these issues are being addressed by different programming languages, we can probably see in the coming slides. Fine. The exclusivity of an object, right? Coming to this particular design issue, everything is an object. There are certain language, like for example, Smalltalk, right? Where everything is an object, or even in Java, you take everything is an object or class, rather, right? So advantage of having this everything as an object is elegance and purity. You find only the object. You don't find any other kind of data. Rather, for example, in C++, you find both. You find objects, you find functions also, rather, right? You find data also, right? You find, in addition to objects, you find other things. So when you have, in addition to objects and other things, then you can't say it is completely object-oriented, but of course it's an object-oriented. For example, few languages where you have only the object, for example, Smalltalk and all that, I think you can say it is purely object-oriented, right? Disadvantages: it slows the operations on simple objects. If you have a simple object, in the sense that you don't have much of operation with particular objects, you have only very few operations, then in order to implement even a small or a big one, then probably the kind of procedure that is rather required is going to be the same thing. So where you find the operations will be a little slower. This is one of the disadvantages of having all the objects to be only objects in your programming language, right? Add objects to a complete typing system. You can have, of course, objects to be added with the data type. That means which particular type of class that respective object is going to be belongs to, right? Having that, it will be an advantage for the user to make the operations faster on simple objects, right? Of course, the advantages results in a confusing type system when you have defined with respect to a type, complete type itself. Include an imperative style typing system for primitive, but make everything else object. The advantage of having this is fast operation, simple objects, and relatively small typing system. Disadvantage is still some confusion because of the two type systems, right? Like in C++, you have most of the objects are being bounded or belongs to a respective class at the compile time itself. But if you want certain objects to point to certain other kind of data, also being possible with the help of generic classes, right? Like templates, right? So the knowing of the type of data on which this respective object is going to be implemented will be known at the runtime. Fine. If you have such kind of thing, the operations will be a little slower, because what happens is in instance of that respective type belonging to that data has to be first created, and then this object has to refer to that respective type, and then it has to then start the implementing the same, right? Are subclasses types? Yes. Does an is a relationship hold between parent class object and an object of the subclass? If a derived class is a parent class, then objects of the derived class must behave the same as the parent class object. A derived class is a subtype if it has and is a relationship with its parent class. Subclass can only add variables and methods and override inherited methods in compatible ways. So in what how the programming language are going to deal the subclasses, subtypes, right? Like you have the subclass in the sense the class who derives the base class are nothing but the derived class, right? So derived class belongs to certain type, and but then when it inherits the base class, it will be inheriting the base class data as well. So we will both data will be allowed and then can be implemented. Yes, in certain programming language, for example, C++ and Java, you can find both are allowed, rather, right? So it depends from particular programming language to particular programming language how they are going to deal, and then how they are going to fix the solution for having when the different type of data available from base class to derived class, rather, right? I'm stopping here.